OSPF. Let's start with OSPF today. Now, the way we try to do like the Hangout is try to make it as interactive as possible, and we try to make it simplify things as much as possible. And we're not rushing anything. We're not in a hurry. Um, the main purpose is to fill in like the gap between personal study and videos that we're using and all that stuff. So OSPF. So where do we start? So what's your understanding of OSPF? Who wants to go first? Mark, you want to go first? What's your understanding of OSPF?
Um, Not much, but I'll give it a try.
Yeah, sure.
It's a link state protocol.
Yeah, right. So let me write that down. Link state protocol. Yeah, yeah. And what else?
Um, it uses
Link state
metrics, I
protocol.
think, to does it use
Cost.
metrics?
It is the cost.
Oh,
Cost.
cost. There you go. Yeah.
Okay. Kevin mentioned costs. The reason why I'm writing all this is because the way we do the Hangout is we try to make it interactive, which means if you mention anything, you have to defend what you mentioned. So in other words, if you've mentioned anything, you have to explain it to us.
I'm not saying a word.
So the things that you've mentioned, so you get ready to mention like how to explain all these things and help us understand all these things that
I
you've
think
mentioned.
the administrative, I think the distance is 110.
Administrative distance is 110. Okay. What else? You can type JM. You can type if you want to type to join in. Yeah. So 110. What else? What else about OSPF? Per many, I can't even hear per many today. It's quiet today. So administrative distance is 110. What else about
You have
OSPF?
to have a relationship. The routers have to have a relationship with the neighbors. Am I missing something?
Adjacencies.
Yeah,
Oh, okay.
has to build that relationship in order to um
Neighbors.
in
Ah,
order to correspond. Yeah.
adjacencies. Someone mentioned adjacencies.
Mhm.
Yeah.
Yeah. What else?
It just sends out what do they call it? Hello
Ah,
or
Hello
okay.
packets.
yes. Hello.
Sent out hello packets. Yeah. What else?
And the designated router is what updates or sends out the changes to the network.
Sent out changes to the network. Yeah. What else?
Updates every 10 seconds or 30 seconds, something. I forgot which one.
Update
Yeah, it's
every
both of them. It depends on the type of
second,
link
Yeah.
state.
30 seconds. Yeah. So Kevin says it depends.
Yeah, on the type, whether it's Ethernet, I think it's 10 seconds, and I
Oh,
think
that's right. Yes.
the
Ethernet.
serial is 30 seconds.
Mm, serial. Okay. What else? OSPF. What else? Any other thing that you think?
It uses VLSM.
Yeah. Uses VLSM. Okay. So all these things you explain, all the yeah, I'm making a mental note of the person that mentioning what. So Mark, I know the
I
things
think
you've mentioned. Kerry, I know the things you've mentioned. So this is VLSM. What else?
somebody said there was a. I think JM said something. There was a master.
So,
Yeah, I haven't seen James saying
so
anything,
Mark
No,
is
so
he did.
Mark
oh.
is setting people up now.
What's that? No, no. Yeah, I saw him type it there. Look in the chat thing.
Which one is that? Chat. What did they say? Papa.
DB and BDR.
Ah, what is that? I didn't see that. How come I didn't see that?
It's right. I see
Oh,
it
okay.
right there.
Yeah, that's Pameni. Oh, Pameni. Yeah, Pameni says
Oh, okay. Okay.
DB and BD how? Ah, okay.
Mhm.
That's something new. DB. Is it DB? Do you agree it's
Yes.
DB? It's DB, you sure?
Mhm. It's designated, no, designated route DR,
Ah,
and
okay.
then the backup DR.
So let's change it. DR, yeah.
Mhm. And then the backup designated route.
I guess the best place to probably begin with is to say routing protocol. So what exactly is the job of routing protocols? So in your environment, you have usually if you're like a small to medium sized business environment, if you're like in one location, you just have one router in your environment. It's when you're like a big company and that you're going to be, dealing much with these things like, routing protocols and all that kind of stuff. If you're like a huge company, if you're like a small to medium sized company, you only have one router, one firewall that's just taking you out to the internet and nothing more. So, what's the whole purpose behind these things called routing protocols? Why do they exist?
To choose the best route to send packets,
Yeah,
the best and fastest route to send packets.
good one,
So
Or should I
this
say best and reliable route to send packets?
good one. Mark, you were
these
saying something.
these protocols handle the data from like the computers, or is that how this works? Or
Kevin, you
I mean,
want to
what does it
help
actually do?
about with that? Kevin, do you want to help out with that? So, Mark is asking the question.
Go again. What's that question?
I mean, I know OSPF and all the other protocols, but what do they actually do? Like, how do they interact with the rest of the network, the computers and the data coming from, like, say, an end user or something like that? Is this what carries the data
Well,
across the network?
well, to what I understand is a computer sending the information. Of course, if you have switches and routers in your network, it would then traverse from the switch to the network to the router, and the router would then look in the routing table and send it to the best route. The the OSPF or the different routing protocols would be the type of protocols, how it actually goes about sending it. If it was using RIP, which is a routing protocol, it will use the next hop. It will use hopping from one router to another. If it is using OSPF, I think it uses the COS to send it. So it's just a different method in sending the packets the best way.
Very
So
good.
it's like
Yeah, yeah.
the carrier. It's like the delivery person. It picks up your data and transfers it or brings it to its destination, right?
Right.
Okay.
Very, very nice answer. Very, very nice answer, Kerry. I agree with that. Um, so what I'll do is I'll try to break down exactly what Kerry just said because if there's something that I usually say that Mark knows in our hangout is that as IT people we use a lot of. If Mark, do you remember what we usually say? The IT people use a lot of terms, right?
All
And
right.
with a lot of terms that if we're not careful can get really complicated quickly. Like for
Yes.
example, we've mentioned a lot of things when we're describing OSPF, and the beauty is breaking it down so we are clear about what they actually are. For example, I can come and say, oh, I configured this adjacency, and then this adjacency linked to this one, and then I've done the whole MPLS configuration, and you're like, now I can't sleep for the rest of the night because now I have to figure out what is adjacency and what is MPLS and what is all these things. So what Mark said is, what's the relationship between our routers and the rest of the network? So now I have some PCs on the screen. So you can see some computers there.
Mhm.
So can I have a router here and then go connect my computers to these routers? Can I?
You can connect, I think, to the console one,
No, what I
but
mean is
then,
not just for the console. I mean, now let's say this is the um, one emulation. Let's say this is the internet. Yeah.
mhm,
Um, our router is
you need a.
connecting to the internet. So now this is like the whole world. This is where Google is. This is where Microsoft is. This is where
Mhm,
Amazon is. This is where everybody are.
mhm,
And we have a router here, which the ISP comes in. They have whether DSL or VDSL or ADSL, whichever one. They've given us this connection, and then we'll take that connection, we plug it into our router. But now inside our network, we have PCs So what's the relationship of these PCs to this router? So can I go take this PC1 and just connect it to this router, PC2 connect it to this router, PC3 connect
It
it to
will
this
be
router?
best.
Can I do that?
It will, you can do, I think you can connect, depending on how many fast Ethernet ports are on the router.
Hmm?
But then wouldn't it better be to use a switch, which will,
Good one. You've mentioned something really important because Mark, yes, Mark, what do you think? Let me ask Mark first. What do you think? Can I take these pieces and connect them to this router?
Um, sure.
Yeah, because yes, yeah, yeah, which I like. You know the reason why? I'll tell you the reason why is because what we're actually discussing is really something which is really really nice because it took like years. It took me like years to get there. I told you the first course training I went for CCNA. I could not understand why our instructor would give us a router and say, here is the lab book, and in the instruction it will say, type this command. The command will be type this command IP address 10.1.1.1 255.255.255.0. He said, type that command to give this interface an IP address. And I'll be like, whoa, that's what we need to do in this lab. So I'll type in the command. And then it will say, now connect to the switch. And then I will try to type in the command on the switch, IP address 10.1, and it will tell me the command does not exist. And I'll be confused. What in the world is going on? I mean, I just typed in the command, I just plugged into a port, right? And the command worked, and I just plugged into another port. Now you're telling me this command is not working. What is going on? So let's go look for Cisco router first, and then let's look for Cisco switch. This will help to understand, just to break down a few things. Even if you understand it before, it will help to break them down. So let me bring, yeah, let's use this one. It's a nice picture. So let's go copy image. Um, let's bring our paint. Let's paste this image here. So we have a router here. Let's go back and get ourselves a nice switch. And then let's see. So let's get a switch. Yeah, that is kind of like, yeah, let's get this one is better. So let's go copy image and let's go, yeah, here we go. We have a router and we have a switch. See this port, so this will answer your question, Mark. You see this port on the router, this port that we're looking at here, this one on this router, this port is different from this port. What is the difference, Kerry? What's the difference between this port and this port?
and I'm thinking one is, well, well, I'm not sure. You have
You know, I know you.
Ethernet and you have fast Ethernet, you have gig Ethernet. It depends. I'm not really sure what I'm
I
seeing.
know
I'm
you know
seeing
the
a
answer.
port.
Yeah, I know you know the answer. Maybe it's the way I've asked the question. Is that this
Okay.
port on the router, it's a layer 3 port.
Oh, yeah, that's probably the way you asked the question. Yes, it's a
Yeah.
layer 3 port. On the
And this
switch, it's a layer 2.
exact. So what does that mean? That's like one of the things I mentioned
Um,
that as IT people we can try around these terms. Now we've confused Mark some more. So Mark is
I'm
now
sorry,
wondering
man.
what is layer 3 and what's layer 2.
The layer 2 switches deal with layer 2, and that means that they look at the MAC address, which is the physical address on the device. And the layer 3 is an example of an IP address like what he gave before, 10.1.1.1. That's an IP address. So there are two different layers. You should already know the OSI layer,
Hmm.
and that will differentiate layer 2 and layer 3.
Yeah. So Mark, that's the whole point. The whole point is this: is what Kerry said that you see the port on the switch, it's a layer 2 port. It can only have a MAC address. It cannot have an IP address. It
Okay.
cannot. So you cannot go, on your computer, you have a port at the back of your computer. Now
Hmm.
you go into, control panel, network and sharing center. You can give your computer the network card and IP address, right?
Right.
The reason why you can do that is because the network card on your computer is a layer 3 port. But you see, the ones on the switch, they look the same, but they are not actually the same. The one on the switch, it's a layer 2 port. It cannot have an IP address. The one on the router, it's a layer 3 port. You can assign an IP address to it.
Hmm.
So what that means is this, for the question that you're asking. So what that means is this, is that in an environment, what you typically have is you have your devices here. You now have a switch here, and the switch is connecting all your computers. So remember all these ports that you're connecting them to on the switch. So your computer, all the ports have IP addresses, right? But all the
Mhm.
ports on the switch, they can't have IP addresses. They only have MAC addresses. So if your computer wants to transfer information from PC0 to PC1, it doesn't need any IP address. All it needs is the MAC address of this one. That's all it needs. And how does it get the MAC address? Carry how?
It,
Yeah, carry on.
How does it get the MAC
Yeah,
address? Um, how does each device, I mean, the PC gets the MAC
yeah.
address?
So now we're not even now our devices are not even connected to the router at all. All our devices
Uh,
are connected to the switch. Now PC1 wants to send an
by,
information to PC2.
by broadcasting,
Broadcasting what?
by, hold on, let's see. By broadcasting there, I'm not sure. I know it's by
You
broadcasting.
yeah,
I'm
you
not
know,
sure
yeah,
what it is.
yeah. Once you hear it, you know what I'm talking about. App.
ARP
Oh,
does.
yes, ARP, right. Yeah, they
And
use
what
ARP.
again? What is app?
Address resolution.
Protocol, right? Address resolution protocol. What does that mean? Address resolution protocol. Because now Mark, I won't allow you to confuse me. Now you have to break it down for me. Address
But
resolution protocol.
I have I have a
Yeah,
question.
please.
You're
Yeah.
saying it's using the switch uses ARP?
The computer here wants to communicate with the
Uh-huh.
computer here.
Oh, yes.
So how will it
It,
get?
u-
Yeah.
it uses the IP address
Hmm.
and it sends out uses the IP. I know it has something to do with the IP address when it's
Let's go this way.
broadcasting.
Yeah, 192.168.1.1. Let's say this 192.168.1.1. That's that PC here. And this other PC, let's say
Oh,
PC3
the
here.
source address and the destination address. So it puts in that in ARP, and I think in the message it's asking for the MAC address, and that's how it resolves it.
Yeah, yeah, exactly. So, in other words, see, here's the thing, Mark, is that now, the router is not even involved at all. The router is out of the question now. Now we're talking about computers connected together on a switch. This one has an IP address of 192.168.1.1. This one has an IP address of 192.168.1.2. Now they are connected together. The only reason why they have IP addresses is not so that they can communicate. The only reason why they have IP addresses is because they can communicate without IP addresses. These computers here. The only reason why they have the IP address is for them to use it to find the MAC addresses of each other. So 1.1 says, I want to communicate with 1.2. What it does is send a broadcast like what Kerry said. And what is the broadcast saying? It's like, hello everyone. I'm looking for the MAC address of device with IP address 192.168.1.2. I'm looking for your MAC address. If you have that MAC address, if you have that IP address, send your MAC address to me. So PC1 will receive that information and look into it and drop it. It's like, yeah, it's not for me, drop it. PC2 will look into that information and go, well, this is not for me, drop it. PC3 will look at it and say, oh, that's my IP address. So then I'll send my MAC address to this guy. And then this guy can now communicate with me based on my MAC address. Now, the router is not even involved at all. Where the router gets involved is this, is that now this one is 192.168.1.1/24. This one is 192.168.1.2/24. PC1 now says, okay, I want to send an information to a computer with IP address 10.1.1.2/24. Now, this is not on this network, is it?
No.
No. Why is it not on this network?
It's a different different address
Yeah,
than the 192.
yeah. Let's just simplify it for now. It's on the same IP address. It's on the same. It's on a different IP address than this one. So now the router only gets involved when something needs to go out of its network. So now this one is like, hold on, this device that I want to communicate with is not on my network. So if I send an app, it's not going to get it. So the only thing I can do is send the information to my router here and let my router figure out how to get this information to this network. I'm not sure if you get the point. So typically what you have on your network is you have your router also connecting into your switch. And your router will also have an IP address on the same network, which will be something like, I know this like just a revision and stuff like that, but 192.168.1.3/24. So your router will have an IP address on this network, and then this one, you configure this one as the default gateway of these devices. Do you get that, Mark?
Yeah,
And
yeah,
what does default gateway mean? Default gateway means if something is not in my network, I'll send it to you. Oh, no problem, Kevin. I'll send it to you to figure out how to get it to where it needs to go to. So this is the background of what brings us to routing and routing protocols. Because now on the internet out here that we're representing with a cloud, it's not actually just a cloud like that. It actually looks like this in the real world. It actually looks like a bunch of lots of routers, lot and lot and lot of routers, all connected with one another in crazy ways. You know, this one connected to this one connected to this one connected to this one. Yeah, if they have enough ports. This one connected to this one. You get the point? So they are all a bunch of routers in what we call the cloud. They are not just clouds. They're just a bunch of routers everywhere. So this one is connected to this one. Yeah, they're all connected together. You get the point? So
Yes.
yep.
yeah. So they are all connected together. So how does my router know? Maybe 10.1.1.2 is on this network. But how does my router know that? There are two ways. I can either go on my router and manually configure it and say to my router, see, if any packet comes to you and the packet is saying, I'm going to this destination network, this is where you send it to. You send it outside this interface to this IP address. And your router is like, yeah, I'll take that information. But the problem with that is too static. Because what happens is if this one
It's
goes
not.
down, exactly, if this one goes down, your router can automatically detect, is there another way that I can get to that same network? Your router is like, I've been told if there's a packet that's going to this network, I should send it down that path. Now that path is not available. I know nowhere else to go. I just have to send it down that path. So you have a static network that is not dynamic. It's not like a living being that can adjust to anything that happens. So what routing protocols provide us is that all these routers can be communicating with one another. So that if this one says, "Oh, sorry, something just happened, and this part just got down," immediately this router will contact my router and say, "Don't send anything via router 2 because the part to me just got down. If you want to send anything, you can send it through this other part." You get the point? So now
Mm-hmm.
your network is dynamic. They can learn automatically when something fails. They can learn automatically when something is available. Not only that, they can learn automatically the best direction to take, like what Kevin said, the best path. Because what happens is, let's say this one were to be connected to this one, and let's say this link here is just um, maybe this one between this one and this one is 1.5 meg, between this one and this one is 1.5 meg. But between this one and this one is 1 gig. Between this one and this one is 1 gig. Obviously, this one is much faster than this one. But if you don't use something like a routing protocol, your router won't be that intelligent to know that if I send it via this path, I can get there quicker than if I send it via this path. Because that's where routing protocol comes in. It brings intelligence. It brings being dynamic into our network where we can adjust to failures. We can respond to failures dynamically, and we can route packets intelligently, following the best path that is available. Like what Kerry said, we have different routing protocols behave differently. There's a routing protocol called RIP, and RIP is a very low intelligent routing protocol because the only thing RIP understands is up count. So what does that mean? Which we'll get into. What does that mean? Let's say there's a router here and this one here. Well, let's delete one of this one. Let's delete this one. Yeah. So now let's say this one is here. Now this is just one router to here, and this one has two routers here. The only thing RIP uses to choose the best path is RIP says, how many routers do I have to go to get to my destination? That is what I'll use to determine the best path. That is how intelligent RIP is. RIP is like, the only thing I can know is that if I want to go via this way, I have to go, if I want to send this packet via this way, I have to go to router 1 and router 5. And it's like, yeah, that's like a really, really bad road. But this one, I only have to go to router 4 and I'm at router 3. Yeah, that's where I'm going to. But what RIP does not understand is that this one is a 1 gig link. This one is a 1 gig link. This one is 0 0.1 megabits per second link. RIP doesn't understand that. And RIP will send your package through this way. Even though you can get there way much faster through this way, RIP is like, well, I have no idea what bandwidth means. The only thing I know is up count. The only thing I know is I can pass through 5 routers to get there, and I can pass through 1 router to get here. I have no idea which one is the fastest. I just know this, so that's why they call it distance vector protocol. Which brings us to the very first thing that Mark said, link state routing protocol. So what does that mean, Mark? Link state, what does it mean? Link state routing protocol.
Does he does he use the metrics to determine?
Again, you're going back to the normal height route that we said. Now I'm more confused. Does it use the metrics? Now I'm more confused. What is metrics?
Yeah, I'm so confused. I don't know.
So now we have to go down that part of what is metric. Then you say, well, it uses costs. So I'll go, what is costs? So what about you, Kerry? What do you think? What is link state? When they say link state protocol, what does that mean? Link state protocol.
It's just a protocol that sends out its information relating to the router,
Mm-hmm.
and the costs associated with it, the costs associated with that link. And I'm not sure if.
You're absolutely. I think that's a good answer. That's a good answer. But in terms of that, what a link state protocol means is that the routing protocol can understand the links themselves, information about the links. They're not
Mm-hmm,
just concerned about like distance vector, which is only concerned with the distance to the destination in terms of the hub. It can
mm-hmm.
understand the information about the links. So, for example, OSPF is a link state protocol. It can understand what information can OSPF understand. Anyone knows what information can OSPF understand about the link? It's this.
The bandwidth.
Yeah, bandwidth. That's what. So EIGRP can understand more than OSPF. OSPF can only understand bandwidth. EIGRP what we talk about next week. EIGRP can understand only bandwidth. It can understand delay. Maybe the bandwidth is fast, or maybe the link is really highly utilized at the moment. You get the point. So let's say in our diagram again, in the packet tracer one that I brought up. So let's say even though this one is like 1 gig, and it's really fast, but if everyone is sending packets through this router, at some point it only has limited memory. So at some point its memory begin to be like, oh, okay, I'm filled up now. I can't take it. I can't take more. Then it starts dropping packets, right? Because that's what happens. Which is another topic for another day. You have a router. Your router has a memory. There are different ways that your router can forward information from this one to this one. So you have this one connected to this one connected to this one. So whenever you're sending an information here, the information gets stored temporarily in the memory of this router. So it's called store and forward technique. So it stores it temporarily in the memory and forwards it. It stores it temporarily in the memory and forwards it. So what happens if millions of packets are coming in and this router is like, oh, sorry, I've only got 50 megabyte of RAM. I'm all filled up. What will it start to do?
It can use a different method. You have store and forward, you
Yeah,
have cut through, and I think you have fragment free.
yeah, absolutely correct, absolutely correct, Kerry. So there are different methods that it can use. So it
With
can use, yeah, carry on, sorry.
with the cut with the cut through, it means that as soon as it gets the packet, it
It goes
sends it
through.
out.
Yeah, exactly.
And with fragment free,
Yeah,
it 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 says that it stores the first 64 bits
yeah,
and checks for any error, and
yeah,
if there's no error, then it just keeps sending everything as soon as it
yeah,
gets the info.
yeah. Excellent. Did Mark, is that clear a bit?
Yeah,
Yeah.
that's
So
a little bit better.
yeah, so that's like the whole point. But here's the thing here. AIGRP can understand delay, whereas OSPF is like I have no idea what the concept of delay is. So this one is like, okay, hold on, and there's like a delay on my link, even though I can forward packet more quicker than this route, but there's delay going on here. OSPF is like, yeah, I only understand bandwidth. You have higher bandwidth, so I'm still going to send it to you. Whereas AIGRP can go, okay, there's delay going on here. And AIGRP has like lots that it can use. Lots more, it can understand lots more about the link than OSPF can. That's why many people say, yeah, AIGRP is better than OSPF, but you can. That's for another discussion, another or discussion, another. But the point is link state can understand information about the links, not just, you know, the direction we're going, but information about what's going on the link. So that's what we say link state protocol. So let's put it this way. You go on a router. Sorry, let me not delete this one because we'll still have to discuss them. Okay, let's go. Last week when we were discussing, we discussed that about the routing table because that is the whole goal. The whole goal is you have a routing table. It's the same way on your switch. On your switch, what do we have on the switch?
The switch, we have the
Yeah,
MAC table.
yeah, good, very, very good one. You have the MAC table, MAC address table. So the MAC address table, we have something like this. We have something like MAC address AAA is on port 1. MAC address BBB is on port 2. MAC address CCC is on port 3. The routing table, which is on the router, we have something like this. Network 10.1.1.0. Yeah, I lent it via port 2, and the next hop that you have to send it to is 10.1.1.5. So the routing table is what the router uses to say, this is where I'm going to send this packet to. The switch uses the MAC address table to determine where will I send this layer 2 frame to. The router uses the routing table to determine it. And then we now said something which was a bit funny. We said something last week that the routing table doesn't input every route that comes to it into its routing table. It has a process that it follows before it stores anything in its routing table. And we mentioned, and this is just a bit of revision from last week, that the process it follows the process of prefix.
Hmm.
And what does that mean? Is that if you have a network that says I'm network 10.1.1.0/16, and another one is like, yeah, 10.1.1.0/16. As far as the routing table is concerned, these two are the same networks.
Hmm.
So what it's going to do is that it cannot input two routes for the same network into the routing table. So it has to determine which one of these two will I pick.
It
Whereas
does all
if
right.
you have 10.1.1, which will come down, if you have 10.1.1.0/16 and you have 10.1.1.0/24, it will put the two roots in its routing table because as far as the router is concerned, these two are different networks. So the first thing it looks at is the prefix. Is that if at the networks match, the prefix match, if the prefix match is like, yeah, you are the same network, I can put the two roots in the table. I have to determine which one will I put. But if the prefixes are different, it's like, yeah, I'll put the two of you because as far as I'm concerned, you're different. But if the prefix matches, what does it use after that? Kevin was going to say something.
Oh, I was just about to say routing summarization. It summarizes the route.
Yeah, yeah. But in this situation, like, okay, if the two prefixes are the same, what does the routing table use to determine which route to put in the routing table?
I am not sure.
Yeah, so last week we discussed it. Mark, do you remember from last week?
Um,
Administrative distance.
okay.
And what is an administrative distance? Because it's one of the things we mentioned. What is administrative distance?
How long it's gonna take for it to get to its destination? How much it's gonna? I don't want to say cost, but how to get to its
Hops, maybe.
destination.
What did Mark say?
He said
Hops.
hop.
What?
Hops.
No, no, Mark, you were here last week. let's
Maybe physically, not
let's
mentally.
administrative distance. Like these things, I know that they sound like confusing because they are giving them all these names that don't actually have a relationship to what they mean. Yeah. So in IT, we have names like that. Like on your Microsoft PC, you have something called the boot volume, but the boot volume has the system files. Then you have something called the system volume, but the system volume has the boot files. Then you're like, what in the world are you doing? How come the boot volume has system files and system volume has boot files? Why does it make it that system volume has system files and boot volume has boot files? Why do you have to confuse us? So it's the same way with some of these times. They call it administrative distance, and it has really nothing to do with distance. You know, maybe someone was just in his room and he was like, "Yeah, what will I call this new invention? Yeah, administrative distance. That's the word, distance." So it has nothing to do with distance. Administrative distance mainly really means this reliability. So whenever you see administrative distance, it simply means um, how reliable, or let me not use reliability. Let me put trustworthiness. What that means is that you have a Cisco router, right?
Hmm.
Now you have this Cisco router here. This Cisco router is like I have a way of determining which routing protocols I trust and which ones I trust the most.
Oh.
So that is administrative distance. It's like I have a way of determining which ones I trust. So to this router by default is like if OSPF gives me and OSPF process comes and says, I have a route to destination 10.1.1.0/16. It's like, okay, thank you, OSPF. EIGRP process goes, let's say for some reason you've enabled multiple routing protocols on the router. EIGRP process says, oh, I also have routes to 10.1.1.0/16. This is the
Mhm.
direction. The router says, thank you very much, EIGRP. RIP goes, oh, okay, hold on. I also have 10.1.1.0/16. The router says, thank you very much. Now the router is like, now you're all giving me routes to the same network. I can only install one in my routing table. So I have to,
It's
yeah, carry on, sorry.
it's going to put in the routing table the one with the lowest administrative distance.
Good one, exactly. So that is why administrative distance is the trustworthiness. So now the router has to go. Now I can only put one of you in my routing table because you're all taking me to the same network. So what is the administrative distance? The lower the administrative distance, the more trustworthy.
Mhm.
So it's like the lower the administrative distance, the more I trust you. So let's go to Google. Let's go to Google and let's go default administrative distances. So let's go, and Google should give us a wonderful, yeah, there we go. Look at this. Default administrative distances. It says OSPF 110, EIGRP summary root 5. It says internal EIGRP 90. We'll get to what it means by internal and external later. It says external EIGRP 170, RIP 120. So internal EIGRP is what we're dealing with in this case. We'll get to internal and external later. But so in this case, it's like I trust EIGRP more. Someone is sending messages. No, EIGRP is not 90. Sorry, OSPF is not 90. OSPF is 110. So EIGRP is trusted more than OSPF. So it's like, so the router is going to go, well, here's the thing. I have OSPF, which has an administrative distance of 110. I have
110.
EIGRP, which has an administrative distance of 90. I
Yeah.
have RIP, which has an administrative distance of 120.
120.
It's like, which one do I trust the most? The lowest one is the one I trust. So it will take the one that EIGRP has supplied and says, you're the one that you're going to be in the routing table. So what will it do with the remaining? What will it do with the one that OSPF and RIP are supplying?
It would discard it.
Well, not actually discard them, because the router, again, remember, one big difference between like a normal Cisco router, sorry, a normal home routers and the Cisco router is feature and intelligence. They've built intelligence into these devices. Is that it's not actually gonna discard them. It's gonna say to RIP, because OSPF has its own database, right? Its own internal database, which we'll get to later. So it's gonna say to OSPF, the route that you're giving me, just keep it in your database. I may need it sometime else. Let's say the one that EIGRP is telling me that route were to fail, it's gonna go to OSPF and say, can I have that route again, please? But the one for VIP, because VIP does not have its own internal database, what it's going to tell VIP is that keep trying to put it in the routing table. So VIP will just go like a dummy. Well, I will try to put it again in the routing table, and the router will go, no, I'll reject it. He said, I will try to put it again in the routing table, and if you go, no, I'll reject it. So maybe one of the times this route will have failed. He will have discarded it. Maybe this one too has failed. He will have discarded it. Then VIP will come one more time and VIP will go, can I put this back into the routing table? And it will say, yes, you can put it back because I don't have any route to this network again. You get the point? So all the information that I just explained now, if you go on the community page, there was a link that we posted last week that has all this information in that. So let's move on. So that's the administrative distance, right? Which is the reliability of the network or the trustworthiness of the route. It's like this is how much I trust the route. But what now happens in a case? What happens in this case where let's do let's do something good. So VIP, let's go this way. So we have one router here, right? This is our source. This is the destination we want to go to. Now this one, these are the routers in the middle. So this one goes, well, I can get you to where you're going to, this way, and this one goes, yeah, ran out of spot, yeah. But you get the point. So this is destination. These are the paths to it. So let's say these routers are all running RIP, or they are all running OSPF. So what we have is that OSPF is presenting us with two paths to the same network. So in other words, what we have looks something like this. What we have is a situation where we don't have EIGRP or OSPF and VIP now. What we have is OSPF saying, I have a route for you to this network, and the administrative distance for OSPF is what? 110, right? And
Mm-hmm.
the same OSPF is telling me I also have another route to this same network. So in other words, the administrative distance is the same. So the router cannot use the administrative distance to determine what to put in the routing table, right? Because the administrative distance are the same. Is that clear?
Yeah.
Yeah. So in this situation, what will he use? Mark, what do you think? What will he use?
I'm confused.
So in other words, now we have now the ones we mentioned, we said now these are three different routing protocols presenting the router with routes to the same network, right? So the router will go, I trust this one more, so I'm going to put the route that this one is giving me in the routing table. But what happens in a case where the same routing protocol is providing two paths to the same network? So in other words, you have something like the one that will show up here. So what you have is you have this one running OSPF, this one running OSPF, this one running OSPF. And OSPF is telling this router, that you can take router 3 to get to router 1, or you can take router 2 to get to router 1. So the same routing protocol is giving this router two paths to get to this destination. Is that clear at all?
Yes.
Mark, what do you think?
Yeah.
Let's just carry on. It will the light bulb moment will come. Don't worry.
Yeah, no.
Just keep your hand there. The light bulb moment will come. So in this kind of situation, what do you think? What do you think that it's going to use to determine what to put on in the routing table? So what will he use? Kevin, what do you think?
As a bandwidth.
Bandwidth in what sense?
Well, with the OSPF, it looks at the cost, right? How much it costs to, because it's going to be looking at the bandwidth, the width. So if you have both same network and both of them using the same administrative distance,
Mhm.
then the next thing that would differentiate would be like for each. So which one would be faster?
Yeah, which is absolutely right. But in this case, to generalize it, it uses this thing called metrics.
Metrics, okay.
And what does metrics mean? Again, we said administrative distance means trustworthiness, right? So when
Hmm.
you hear administrative distance, just think trustworthiness. So this is based on routing protocols. Metrics means prefer, if you permit me to use this word, preferability. In other words, so in other words, this is not about trustworthiness because I trust the same routing protocol the same. But
Hmm.
now, which one do I prefer from these two options? So now it's like, okay, I have to determine which one do I trust the most. But now, I mean, OSPF, I trust you as the same OSPF process, and you're giving me two routes to the same path. So now, which path do we prefer? And that's where metrics come in. Now, metrics is different for routing protocol. For RIP, metrics is the hop count. In other words, how far are you away? How many routers do I have to go through before I get to my destination? For OSPF, the metric is called cost.
Hmm.
It's called cost because people confuse metrics and cost. Metrics is not cost. Metrics means what a routing protocol uses to calculate how much I prefer a link. So for OSPF, it's called cost, and the cost is actually just bandwidth.
Hmm.
For EIGRP, that's a whole another topic because it uses a lot. You can use bandwidth, you can use delay, you can use multiple things. So, and how does OSPF calculate the cost or the bandwidth?
It used some mathematical calculation thing
Yeah,
that's called the Jenk something.
well, not we're not yet at that stage yet. We're not yet
Okay.
at the Dijkstra algorithm yet. So now
Yeah.
we're talking about the routes now. So what OSPF used to determine which routes do I prefer? It's called the bandwidth, and how it calculates the bandwidth is this: 100 million divided by the bandwidth in bits per second. What does that mean? Let's try to break it down. So, Mark, I know sometimes it can get a bit scary, but don't give up, yeah?
I'm not giving up.
Don't, yeah, that's the key. Don't don't give up. let's take this one away because let's we make it look more complicated than it actually is. So let's take all those complicated diagrams away. So let's make something simple. So we have this one, and we have this router connected to this one. Now let's say this interface. Well, let's cancel that. Let's say this interface let's say this interface is 100 megabits per second, and let's say this interface is 100 megabits per second. So that's let's not 10. So let's say that's 100 megabits per second. So what OSPF will do is it will go, well, that is 100 million divided by 100 megabits per second. If you convert that to bits per second, that is 100 million. So that is divided by 100 million, and that is equals to 1. So it will be like the cost for this link is 1. Yeah. But
Okay.
let's put it this way. Let's say there's another router here. I think this time around I may have to get more ports so that I don't have to. Yeah, let's just get more ports. Yeah. Have I powered it off yet? Okay. Are you off now? So how do I start? Yeah. Okay, here we go. Yeah, here we go. So let's go. This one is connected to this one. Okay. This one still needs more weak ports. So let's get. Okay, let's just power all of you off. We'll get there. Let's power this one off too. And yeah, here we are. We're there already. Yay. Okay. So this one to this one is 100 meg, right? So what OSPF will say is that if I want to go to router 9, the cost is going to cost me a cost of 1 to get here. So let's say this port on this one is 10 megabits per second. So this one is 10 megabits per second. This one is also 10 megabits per second. So this one is 10 megabits per second. This one is 10 megabits per second. So what SPF will do is do the same calculation on this link and go 100 million divided by, this case it won't be 100 because that's 100. If you take 10 megabits per second to bits per second, so that's 10 million. So that's 10 million. So that equals to 10. So it will say if this link, from this link to this link, it will cost me 10. And from this link to this link, it will cost me another 10. So it will say if I want to get to router 9 via router 10, it will cost me 20. If I want to get there via router, just go directly, it will cost me 1. And it's going to present these two routes. It's going to present it to the router and say, yeah, router, I know you trust OSPF the same, yeah. So now you're not going to judge based on administrative distance, but I have 2 routes for you. If you go via router 10, Mark is scared. Is
Huh?
that Mark? Oh, okay, it's not Mark.
No, no,
Sorry.
no.
He's here. Mark, I tell you the key. The key is just don't give up. That's the key. Just after you listen to this, maybe like, I don't get it. Then when you go back later to watch some CBT Nugget video or Twin Signal video, you understand it a little bit more. Then maybe when you're in the classroom, all of a sudden it will click. You'll be like,
Yeah,
yeah,
exactly.
I get what you're talking about now. But then the other thing is, if you didn't hear it before, you won't have understood it when you're hearing it like the 3rd time or the 4th time.
Right.
So you say if you're going via router 10, the cost, so you say the same route to router 9, it will cost you a cost of 1, or the same route to router 9, directly, sorry, via router 10, via router 10, it will cost you a cost of 20. So it will say to the router, these are my own preferability calculations. This is the way I prefer this route. This one is 1, this one is 20. So the way the router also does it is the lower the metrics, the more it prefers it. So if the metric is lower, it prefers it more. So the router will go and say, this is the route I'll put in my network because of this matrix calculation. Is that clear with Kerry and, and Mark at least
Yes,
a little bit? Yeah.
Yeah.
yes, that's clear.
Yeah. So that's like in the case of the calculation of the metrics. So let's go a bit further here in terms of our discussion of that. So the whole OSPF process itself. Let's even go ahead and yeah, I think that's the best thing. Let's go ahead and configure OSPF. So let's do some good quick configuration of OSPF here. Yeah, so let's go bring a router, um, router 36 and another router here. So the whole goal is we want to get OSPF working and one router here. So we have router 2, router 3, router 4. Let's get some PCs, some of our VirtualBox PCs. Client 1. So this is kind of thing that you can do with GNS2. We have client 2. We have no, sorry, I don't want client 1, client 2, client 3. I want test 1, test 2, test 3. Test 1.
So do different devices use different protocols? Is that,
Yeah,
how do you know to set up, all the different ones?
I mean, you mean for routers and switches, do you mean that?
Yeah, yeah.
Yeah, definitely, because on every layer, like what Kevin mentioned earlier, on every layer, Kevin can probably explain this one. Kevin, will you help Mark with the discussion?
Um, the question you said if different routers use different
I mean, like, how do you know
know which one to use?
one uses OSPF or the other one uses the EIGRP? What uses that? Like, what determines what uses what protocol, or do you set that up yourself?
You can set it up yourself, but I'm not sure what determines what. David will be the best person to answer that.
I mean, can you just set it up so it just uses OSPF, or can you set it up so it uses multiple
You
different?
can set, yeah, you can set it for it to use, I
Okay.
think,
Yeah,
multiple. Can
you're
you
right.
set it up for use multiple?
Yeah, no, absolutely right. No, you're right. You're right. The answer
Because
is right. Yeah.
what you have to take into consideration, especially if you're connecting to routers outside of your network, you don't know or necessarily know what routing protocol that they're using.
Yeah.
So it will be always good to set up all so that you will be able to communicate with them because you want them to have the same routing protocol when you're communicating.
Yeah.
I think. Not
Yeah.
just
That's exactly what I was looking for.
Yeah,
That
yeah.
answer.
So what Kevin is saying is that let's say like again like we said, like normally a small to medium sized company won't be using
Hmm.
like all these routing protocols and everything we're mentioning. Basically, you're talking about companies in that has offices in different locations, that has more
Mhm.
than one office, or much bigger companies and all that. So you have your internet connection here. Your internet connection here that we're drawing as a cloud, what it is if you go on the other hand of your ISP, it's a router that's there. That's all. All they have there is a router. So you have a router connecting from your location, office location, to your ISP. So you have to know what routing protocol they are running here if you're gonna be able to communicate with them.
Hmm.
So here's the thing: is that most devices nowadays, I mean not most, any enterprise router nowadays run OSPF, any one of them. So if you buy HP routers run OSPF. If you buy Brocade routers run OSPF. If you buy Cisco routers run OSPF. And the thing is, OSPF is like a standard. So it's the same on HP, it's the same on Brocade, it's the same on Cisco. So which is one of the reasons why OSPF is more popular, because you can use it basically within any vendor or with any vendor. So it doesn't matter what the other person is running. If it's an enterprise grade router, you can be assured it's running OSPF or it can
Okay.
run OSPF. So EIGRP, which is much efficient, but it is Cisco proprietary, which means it only runs on Cisco devices. There was something that I was reading about that Cisco was going to EIGRP release, that Cisco was going to release it so that it's going to be open source. Yeah, I was reading this one sometime that that they were going to release it, so it's not going to be proprietary. So as at then, EIGRP only runs on only Cisco devices, but Cisco was going to release it to the general public so that everybody
Oh,
can implement it. Yeah,
okay.
yes. So basically, like here's one other good thing to note, Mark, is that the founder of Cisco, not the founder, sorry, the CEO, John Chambers, he came out and said Cisco is not a hardware company. He said Cisco is a software company. And that is true in the sense of when you see like a Cisco router, the hardware is not what is like the big thing. The main thing is the software that it is running. So what that means for this discussion is that um, you're saying, can you run OSPF, or what determines if you can run OSPF or EIGRP? What determines that is the software that is on the device. So the software has been built to run this particular protocol. I'm not sure if that helps at all. Is that helpful at all, Mark? Did you answer your
Yeah.
question?
Yeah. It's all coming together
Yeah,
piece by
yeah,
piece.
yeah. We exactly that's what
Yeah.
happened. That's the key. So little by little. So let's just quickly do some OSPF, and then we can use this too. Here's the other thing. Should I tell you the other thing, Kerry? Um, the other thing I like about GNS3 is that you can use um, let's use fast Ethernet. You can use Wireshark with it, and that is huge. That's a huge one. You know Wireshark, right?
No, what is Wireshark?
Yeah, so it's a packet capture, packet analysis tool. It's also free.
Oh,
Yeah.
okay.
So actually, we're going to use that a bit today because it will help you understand. Because all your routers or devices are sending around is they are sending packets around. So Wireshark will allow you to capture those packets and look inside those packets, and now you can understand exactly what they are sending.
Oh, it's similar to what they have in the packet tracer where you can run the simulation thing and then see
This
what
one is this
happened.
one is even much more detailed. Like this one will show you the
Okay.
actual package. All the things we're talking about, OSPF when it has things like process ID and router ID, you actually see all of them, like where, like all what is actually going on. So here we have ourselves a situation where we have three networks. So we have a router here connected to a switch connected to this PC here. So yeah, so we have all this one. So let's go ahead and start all of them so we can begin to play with them. So while they're starting up, let's label them a little so we know what we are configuring. So this is OSPF is really simple to configure. Um, wants me to shut them down, I guess. So close power virtual machine, close power off, and then close this one, then power it off. Yeah, few more minutes before the end of everything today. So let's see if it stops my virtual machines. Yeah, good one. Now we're back in business. Our virtual machines are starting up. So you see, this is why this is like really interesting because it's starting up our real virtual machines themselves.
Okay.
Yeah, here we go. Virtual machines are started. Yeah, okay. So let's put some labels on this. So let's say this link, we'll configure it for 192.168.1.0. Let me zoom in so that it's clearer to you. So 192.168. Is that better, right?
Yes.
192.168.1.0. Let's call it /30. Let's call this 192.168.1.4/30. And let's call this 192.168.1.8/30. So this is for another time like subnetting and other. Actually, they're like the first set of things that we dealt with in the Hangout. And then we have our machines here, this inner network here. So let's call this 10.1.1.0/24 network. So let's call this 10.1.2.0/24. And let's call this 10.1.3.0/24, which means we can give our devices any IP on that network. So here's the good thing about this is that let's deal first with these devices. So here's the thing I talked about Wireshark. See, I can right click on this link and go start capturing, right?
Mm-hmm.
Go start capturing, and you tell me you want to capture R3 interface F00, and then it's capturing here. So actually, let me view the interface labels. So we can go show interface labels. Yeah, here we go. So we can see what our interfaces are like. So this is interface F00. Yeah. So I can right click on this one and close and go to start Wireshark, and I can see the actual packet that is actually going out of this interface. So this is
Oh.
actually like this is more than just simulation. This is like the real packet itself. So here we go. Yeah, remind me later of that Wireshark. And then you can see there's nothing going out. So this will
Mm-hmm.
help us in our study of OSPF now, in a little demonstration of OSPF. So first of all, let's go to this router called router 2, and let's add IP addresses to it. What I'll do is I'll try to make this bigger so that it will help. Change settings, appearance, font, make it 16, so that will help. Yeah, that's better, right?
Yes.
Yeah,
Yeah.
so yeah, so what I'll do is I'll try to go, yeah, how to. So let's go give interface F00 and F01 IP addresses. So let's go interface first 00, and let's give it an IP address of 192.168.1.1. 255.255.255. What would be the last one, Kerry?
0.
No, not zero. It's /30.
Oh, sorry. 30. 252.
Excellent. 252. Mark, do you understand how she got that?
I just started learning that, but
Yeah. Yeah. Don't worry.
what?
Yeah.
Yeah, it's still kind of Greek to me. I'm figuring it out.
Yep. Yeah. Nice one. Just carry on. IP
Yeah.
address, and then by default, the interfaces of routers are shut down, so we have to unshut it by default. So we've unshut it. So let's do the same for interface fast 01. And let's go up IP address 192.168.1.5 in this case, and then do no shot to unshut it. So again, I can go back to there, and you can see it's beginning to send some packets. it's sending some app. You can see app, right?
Yes.
I'm not sure. Is there a way to maximize this or to make it? Or can you see this, or do I need to look for a way to make it bigger? Zoom.
Yeah, it's a
Okay.
bit fuzzy, but I could actually see
Zoom
Yeah, it's
in.
fine.
Yeah,
some parts of it. Yeah.
that's better, right?
Mhm.
Yeah, nice one. Okay. So now you can actually see that it's beginning to send some packet. One of the packets that is sent is something called CDP, Cisco Discovery Protocol, where it's trying to discover
Mhm.
what router is on the other hand. And you can actually drill down and look at what the packet looks like.
Oh, this is nice.
Yeah, so this is the actual packet that's going on. It's got a time to live on it. You can see it's like, okay, this is my iOS version that I'm running.
Mhm.
It's like this is the address that I have in case anyone needs it. This is the port ID. These are my capabilities. These are my VTP management domain. You get the point. So these are the actual packets
Mhm.
that's going on, and we'll use that with our OSPF learning now. So that is on this interface. Now we've enabled that interface. So we've enabled that. We've done everything with router 2 that we need to do. So the other thing is we need to go to router 3. So let's do the same thing on router 3. So actually on this one, I'll just leave this one small. I'll maximize it later. Let's go conft interface fast 10. Let's go IP address 192.168.1. We use 0 for that, so this will be .1.2, 255, 255, 255, 252, and we do a no shots because by default they are shut down. Every interface on the router is shut down by default. So we do the same thing for interface fast 01. Fast 01, and we do IP address 192.168.1.8, and this time let's say 9, 255, no shots. And there we go. We've enabled the interfaces on this one, so I can maximize it now. Change 16 and apply. And there we go. Yeah. So that one is done. So then let's do the last one, which is this router 4. And then if you go back, so actually let's start capturing from all these interfaces. We don't need to capture this interface again because this one will be capturing this link. This one is already capturing it. So let's capture this interface also. Start capturing. And let's capture this interface also. So let's start capturing. Let's go, okay. And then what I can do is open Wireshark for all of them, and we can start seeing what is actually going on our packet. Router 4. Let's configure router 4, and then now we finish with the interfaces. Conf interface fast Ethernet. Um, interface fast Ethernet 01, and that has an IP address of 192.168.1.8. Oh, sorry, .1.9 was the one we used. 10. 255.255.255.252, and no shots. And then interface fast Ethernet 10. Is it 10? Oh, I think I configured the wrong one because now, so it is 00 actually. Interface fast Ethernet 00, and then go IP address 192.168.1.45. Call this 6.
Stuff is like a whole different language.
No, you get, believe me, Mark, I tell you, like, I believe that I was worse than you when I first started. I mean, in the class, I tell you, I was like,
Trust me.
yeah, Kerry can probably give
It
her
is
own
it
experience.
is weird when you start looking at it, but then
Yeah,
when you start doing, because sometimes you even start doing what, as David said, he was in the class and he was just doing what was in the book and you
Yeah,
don't understand exactly what is in. So
yeah,
Right.
after reading the book twice and then trying to doing some of the video courses and then making my own notes and then playing around with it,
yeah,
that's what that's when you start understanding. You're like, oh, that's what they meant by
yeah,
that.
exactly.
It takes a little time,
Yeah.
but
So yeah,
yeah.
so it depends. Everyone has their own way of getting the light bulb moment. So for me, it usually takes me hearing it multiple times. So even the first time I hear it, I don't understand it. I will just keep listening because I know
Mhm.
all those things are they are all setting me up for that light bulb moment. So I listen to it the first time. I have no clue what the guy is talking about, but I still listen. Then the second time I still listen, even though have just very little clue. Then maybe the fourth time I'm listening, I'm like, yeah, that's it. That's exactly what you mean. I understand what you mean now. But the thing is that if I'd not listened to it like all those previous times, I had no clue what it meant. I wouldn't have understood it when I understood it.
So how do they expect you to know this and when they go through one of those boot camps? I mean, that's impossible.
That's what I'm saying. The boot camp is actually, as the name states, a boot camp. They expect you to already know some of the stuff.
Yeah,
Most of the time, they're on the premise that you work in the environment
yeah,
and you now want to get the certification, so you already know how to do
yeah,
it. You already we're just explaining the terms so that you know the correct term to use
yeah.
and filling in some of the gaps. It's a boot camp. A boot camp is actually a training program where
Yeah.
So whenever I reach that part in the book, I skip because I already understand it from the way that Chris Brown taught.
Yeah.
Hmm.
Yeah. Internet fast. Sorry, my internet connection went off. Um, yeah. Yeah. So I'm almost done with this one. Yeah. So now we can start enabling OSPF. So let's just do ping 192.168.1.1. Let's make sure we can ping the other guy. Oh no. Can anyone guess why I can't ping him?
Pardon me?
Can you guess why I can't ping him? Because I didn't I didn't unshot the interface, I think. I think that's why. No shots. Then do ping. Yep, here we go. Now look at this, Gary. Look at this. You like this? If I go under this one and I go under this one, can you see all my ping?
Yes,
So
yes,
this is
I.
the ping. So I can actually filter it out. So instead of showing every single packet, I can say I only want to see just the ping ones. So I can see
Hmm.
this was the ping that I sent
Okay,
from 192.168.1.2. So
now
this is
I
the actual
understand.
packet
Yeah.
going to 192.168.1.1. The
This would have
protocol
been
is,
very useful
yeah,
when I needed to learn the switching thing when they keep asking questions in the exam about when you're doing a switch and you're on a switch and it's actually broadcasting what happens when it changes address, which address would it have in the MAC address table.
yeah,
Um, it took
yeah,
me a while to understand it,
yeah,
but this would have been so much easier.
yeah. This tool, the person that created this tool created like a really wonderful tool, and it's 100% free. Wireshark is 100% free. So what they've done is they've taken this tool, or they took this tool and integrated with it with other free tools and made it something really powerful. So they integrated it with VirtualBox, they integrated it with Wireshark, they even integrated it with SolarWinds network monitoring too. So they integrated with a lot of cool stuff that they are all free, and it's just wonderful. So yeah, I can see 192.168.1.2 sending a message, a ping message to this one. So that's the ping request. And this one replying, you can see the ping reply from
Yeah.
192.168.1.1 to him. So basically, if I see this one going, sending the ping, and then the other one is not replying, then I know the problem is on the other side.
Mhm.
So really wonderful to another. So yeah, back to OSPF. So the very first thing we need to do to enable OSPF on this router, let's start with router 3, is we have to enable the OSPF process itself. So the way to do that is we go router OSPF, with a question mark, it says process ID. So what does the process ID mean?
It's just an ID number. For what I understand, it's just an ID number which is not used externally, only
Good one.
internally.
Good one. So it's just a random number. So unlike EIGRP, if you're configuring EIGRP autonomous system number, it has to be the same on all the routers. But on
Right.
OSPF, this number is only locally significant. It has no significance outside this router. So you can use any number between 1 and the number that they mentioned. So let's just use router OSPF 1. And what we've just done is we've enabled OSPF on this router. That's what that command has done. But that's on router 3, right?
Yes.
Now, if we go to Wireshark and let's just start capturing packets just for OSPF, or not capturing packet just for OSPF, let's just filter only OSPF packet is what we want to see. And let's go OSPF. Now we see nothing, absolutely nothing. We've enabled OSPF, but we see absolutely nothing. So why is it that we see absolutely nothing, Kerry? Or Mark, what do you think?
Because of
You haven't said anything yet.
Yeah, that's a good answer. But what
right.
do we need to set?
I don't know.
Um, is it because it has to form an agreement with another device? So, and then you have to specify the network and
Oh, it
the
has to
internet.
find
Right. The
neighboring.
adjacent, right, the adjacency. It has to build the adjacency, as you said.
So
So
how does it build the
OSPF has to be
adjacency?
running on the next on the next router. OSPF has to be enabled and start running, and then they both have to be in the same subnet.
Yeah, you're right, Kevin. But here's the thing. Let's go back a bit. Let's go back a bit. What I'm saying is
Okay.
I've enabled OSPF on this router.
Mm-hmm.
Yeah. Now we're not talking about it forming adjacency yet. We're just saying
Oh,
I've
but you
enabled
haven't
it, but
specified.
it's not sending anything out. There's nothing to OSPF. I go here,
Oh,
OSPF
not hello
blank.
package because it hasn't. I think you have to apply to the
So
interface.
good
Apply to the
one.
interface.
Good one. That's the next thing. So first thing we have to do is we have to enable OSPF. Then after we enable OSPF, the router is like, yeah, I have OSPF running on me, but hold on, which interface do you want me to actually go out from to start finding someone to talk to? Because now you've enabled OSPF on the router, and the router is like, now I need to know which interface you want me to go out from, and then try to look for somebody that I can become friends with. And how do we do that? So we have to enable OSPF first, which is the first thing we do, which is using the router OSPF process ID. And then the other thing is we have to enable OSPF on specific interfaces. And how do I do that?
You go back to the router and you go to the interface, whether it's um, interface fast interface 0001, and then
Okay, let me try
you,
that. So let's try what Kevi is suggesting. So Kevi said we go to this one and I go to interface. So we go interface fast 00 and fast 01. So which one do you want me to pick? Fast 00?
uh, yeah, anyone.
Okay, fast 00.
But okay, hold on. I'm trying to make it right. Okay, now I see which one is fast. And then I think you have to say the network and the You have to use wildcard bits.
The network and what card bit. So where do I do that? Is it from the interface?
um, the interface, I don't remember the syntax for it, but I do know that you have to say network, the network address.
So yes,
Uh,
let's make it simpler. So if I go back to router OSPF 1. So you're right. I know where you're going. So you're right, but this is the way. So you do it from under the router configuration mode. So after I
oh,
do router
okay.
OSPF 1, so the next thing, if I do a question mark, you see this command here that says network. It says enable routing on an IP network. Again, that's not as clear
Okay.
as possible. But if I go network, and then it says what's the network number, so that would be probably the interface number or the so in other words, what the network
Would be
statement does is this: it enables OSPF on any interface that is on the network that I've typed in, and it assigns them into a specific area. So in this case, I will just go 192.168.1.0.
0.
Then it says it needs the wildcard mark, which is for another topic for another day. I'll just
Right.
go 0.0.0 dot. Kevin, you want to help? Or Mark? Mark, what do you think?
Um,
Mark is
if
still learning
the
that, so
wild,
that's why I'm not disturbing Mark.
the wild card bit for that, oh my gosh, I have to work it out.
Slash
The
30.
it's touch 30,
Yep.
so it's gonna be 255 would be 0. I have to write it down.
Yeah, no problem, sure. Yeah, Pamene gave it to me, but I'll let you try to work it out too. So,
1632 or J or someone else. 64, 128, 192, 224, 240, 248, 252. It'll be dot three.
yeah, good one. So that was what Pamene gave the answer. So it's dot three. So Mark, you get used to use this letter and order. So dot three area. Let's just put it in area 0 just to make things simple. Now look at this. Now look at this. We have Wireshark where we only want to only see what's going on. So we have Wireshark running here. Wireshark running here is like, yeah, I've not received any OSPF packet. Now if we go here and I go, now I've said I've entered this command OSPF, any interface that is on this network, I want you to enable OSPF on that interface, and I want you to put that interface in area 0, and then I go enter, and look at what will happen. Look at that. Instantly, something went out called an hello packet from that interface.
Yes.
Can you see that? And it's sending it, keep sending it. And inside that, so in other words, now I have a router, right? I've enabled OSPF on it. It does nothing. Then when I go and type the network statement and say, I want you to enable OSPF on this interface, and I want you to put it to area 0, instantly OSPF starts sending out a low packet from that interface. It's like any other router out there that is running OSPF, any other router out there that is running OSPF. Now it's sending a low packet, but nobody's responding to it. So this is a router 192.168.1.2. It's sending it to the multicast address of OSPF 224.0.0.5. But it's like I have no response. So it will keep sending it out. And if we open that hello packet, we can see what it looks like. You can see the default interval is what? 10
10
seconds.
seconds.
You can see the default dead interval is what? 40
47.
seconds. So we can see actually it's like designated router where I've got none, backup designated router I've got none. Here's my network mask. Here's my hello interval. I'm looking for a neighbor, anybody out there, and it will keep sending this every 10 seconds. So now it's sending this packet. Nobody's responding to him. So let's go back to our topology and see what it looks like. So it's sending it out of this interface because this is the interface we enabled it from. So let's go to router 2 and enable OSPF on this interface also on router 2, and let's see what happens. So let's go to router 2 And actually, let's bring up the same Wireshark. Let Wireshark be running in the background. So Wireshark is running there, and then let's bring up router 2. And let's go to interface fast00, and let's enable OSPF. So let's go router OSPF 1. Enabled, but nothing is going to be happening until I go network 192.168.1.0, 0.0.0.3, and put it in area 0. Now look at what will happen the moment I do this. So now you can see that this packet is going from 192.168.1.2 to 224.0.0.5. Now look at what happens. We go enter. Now something is happening. Something different is happening. It's like, oh, okay, something huge just happened. So now we have another hello packet from 192.168.1.1 to the multicast address. And now 1.1 and 1.2 are communicating with one another. And now 1.1 and 1.2 are sharing database with one another. Can you see that?
Yes.
And now they're sharing database with one another. It is like, this my database, this is what it looks like. And they're like, yeah. And then they're sending link state advertisements to one another. They're sending link state updates to one another. So in other words, the very first thing that we do is we enable OSPF on the router. Then we enable OSPF on specific interfaces using the network address wildcard. And after that, network, yeah, I think we'll finish shortly. This one,
Area.
yeah, a wildcard, and what else? Yeah, area,
Area.
yeah, and then the area. And the moment we do that, it starts to send out. First thing it starts to do is to send out something called the hello packet.
Hello.
And by default, it sends it out every 10 seconds,
10 seconds.
or like you said, or every 30 seconds. What determines whether it sends it out every 10 seconds or every 30 seconds?
10 seconds is for Ethernet and 30 seconds is for serial.
Well, not necessarily for Ethernet and for serial, because I could make this one a serial connection and it will still send it out every 10 seconds. So there's this
Or is it
concept
10
called
seconds? Is it the 10-second is the default where you can? I'm not sure.
broadcasts, non-broadcasts.
Mhm.
So there's this type of network, point to point,
Mhm.
point to point, or point to multi-point. So that's what OSPF uses, point
Oh.
to multi-point. If it's a broadcast network, Ethernet is a
Uh-huh.
broadcast network.
Uh-huh.
So if it is a broadcast network, it sends it every 10 seconds. If it's a non-broadcast network, it sends it every 30 seconds. If it's a point-to-point network, which is like in the case of a serial. So let's
Mhm.
see OSPF. Let's bring up. Actually, let's just make sure that we have the right information here. OSPF hello interval. Let's just quickly. Well, uh, something clear. Yeah, I know. For anyone that may not know, there's this application called AdBlock. It's a wonderful application. It's going to block every advertisement. Nice. Yeah, it's really, really nice, especially for people that like watching free movies. You know, all those free movie sites that just bombard you with
Yeah.
advertisement. It will block every single advertisement. Not one of them will show up. It's a really good application, and it's free. Let's see. OSPF. Okay, let me just OSPF a low interval broadcast network. Let's go network type, because that's what it uses. It uses the network type. So we'll finish in the next, I think, 5 minutes. We should round up. Okay, yeah,
Mhm.
here we go. Point-to-point network, another, but this is another stuff. Yeah, broadcast networks, 10 seconds. Um, point-to-point broadcast network, point to multi-point, 30 seconds.
Mm-hmm.
Point to multi-point non-broadcast. Now, this is 30 seconds. Non-broadcast network is 30 seconds. So in other words, this is okay, hello interval, broadcast network 10, point-to-point network. Now your point-to-point network can be serial
Okay.
because if I have point-to-point
Yes,
network,
yes, yes,
yeah,
it
if
can.
I'm running
Yeah.
HTLC or PPP, it's point-to-point network, but it's going to be sending it
Mm-hmm.
every 10 seconds. So this is what it uses. This is the thing to take note of. Broadcast network, non-broadcast network, point-to-point network, point-to-multi-point network. So if it's broadcast or point-to-point, it's 10 seconds. If it's
Mm-hmm.
non-broadcast or point to multi-point, it's 30 seconds. Broadcast
Okay.
is usually things like Ethernet. Point to point usually things like HDLC and PPP. Point to multi-point usually something like frame relay, ATM, X25,
Mm-hmm.
and which is the same thing as non-broadcast. So that's the thing to watch out for when it comes to that. I hope that helps to clarify that. So that is what it uses to determine the LO interval. Now, these two routers are sending hellos to one another, and without us doing anything, they've already agreed and they're already neighbors, I'm sure. So if I go back to my device and go to, let's see, um, just one of them that's working. Let's go with the three and do show IP OSPF neighbor. It will tell me, yeah, I have a neighbor. That's my neighbor. Now they are neighbors without us doing anything. The reason why they are neighbors is because the hello packets that they are sending, they've agreed on some things. So let's see. This one goes, hello, here's my network mask. This one replies, this 1.1, right? And 1.2 is sending this one out. Here's my network mask. This one replies, no, not that one. Let's go 1.1. Yeah. Here's my network mask. This one goes, here's my network mask. It's the same, right? This one
Yes.
goes, here's my hello interval. This other one goes, here's my hello interval. It's the same. This one goes,
Yes.
here's my dead interval. This one goes, here's my dead interval. It's the same.
Mm-hmm.
So that is the reason why they are able to form a neighbor relationship. If any of these are different, they won't be able to form a neighbor relationship. Like for example, let's do something. Let's go um, F00 on router 2 and let's make a change. And I think this is probably what we round up for today. Interface fast 00 and let's do IP OSPF OSPF um, IP OSPF. Let's change the LO interval. LO interval and let's set it. So it's currently set to 10. Let's set it to 5 and let's go to Wireshark again. Let's make sure Wireshark is running and then let's go enter and then let's see what happens. Dun, 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 dun.
He just drank a pot of coffee. Hello, 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 hello.
Yeah. So, yeah. So, okay. IPOSPF low interval 5 and then do show IPOSPF neighbor. Which one? Maybe my guess is I'm probably working on the wrong part. Oh, okay. It's done something now. Yeah, here we go. It says
Mm-hmm.
dead timer expired. In other words, it's like I sent an hello, but hold on, both of them are sending hello, but their timer expired. So in other words, he said, I'm sending an hello to you. You're sending an hello to me, but what you're sending to me in the hello does not agree with what I'm sending to you in the hello. Therefore, we can't form a relationship. Like I'm sending these hellos to you, and my hello says because now if we now go back to the hello interval that this one is sending, can you see? 5 seconds. But this one is like, hold on, I'm sending 10 seconds, you're sending 5 seconds to me. No, we are not in agreement. Therefore, we're not gonna form a relationship. And that way, they're not going to form a relationship. And now, here's another thing I want you to notice. The dead interval was 40 seconds before, right?
Mm-hmm.
Now it's 20 seconds. Because once you change the hello interval, Cisco router or Cisco iOS will automatically recalculate your dead interval to be times 4.
Okay.
So dead interval by
Oh,
default is times 4 of your hello interval. So what that means is that you can lose, you can only lose 4 hello packets before the router goes, I'm gone, I'm done, I'm going down. So
okay.
this one will send an hello, the other one will send a reply. It's like we're not in agreement. Okay, one lost. I'll send another one. So because dead interval is like 4 times the hello interval. So it sends another one, and then the other one sends the wrong information, and it's like we're not in agreement. Then it sends the third one. Then by the time it sends the fourth one, the dead timer has counted down to 0. So it just goes, well, we're not in relationship anymore. Relationship expired. Network is broken. So I think that's where we'll probably stop for today
Okay.
because there's so much more that we could go into details of um, the LO interval, the dead interval, the wait time, and go into details of all this one by one. But I just encourage you to just do a lab tomorrow on OSPF. Look online. I'm sure there are like lots of labs. Whether you understand it or not, go to Packet Tracer. Yeah, sorry, go download Packet Tracer somewhere. Again, it's not legal. You have to be a student of Cisco. So let me put that disclaimer there. So get it. When you can search the internet, you you know what to do. But Packet Tracer, so it's made by Cisco. So go get Packet Tracer and look online for free OSPF lab. There's this one called Free Cisco. Yeah, whether if you have a lab that you can follow, just do a OSPF lab tomorrow. Yeah, whether you
Okay.
understand it or not, just I challenge you, just take it, just do it for tomorrow. Whether you understand it or not, just go through it, configure it again, just configure it again. And then maybe watch one of your videos, maybe CCNA CBT Nuggets. You find it more fun. But I think that's where we'll be. Yeah, we could go on and on, but just for today, that's where we'll stop. So we'll continue again next week.
Okay.
Yeah, nice hanging out with you guys and
Yes, it
Kerry
was
and
good.
everybody. Yeah. So the recording of today's hangout should be up shortly and all that. And I'm not sure. I may probably see Mark again tomorrow for Microsoft stuff if you're around, because Mike just enjoys learning and all that stuff.
Yeah.
Yeah, because what we do is we do Cisco stuff on Tuesday, then Wednesday we do Microsoft stuff, then Thursday we do Microsoft stuff. So yeah,
Yeah.
So
so
you do Microsoft stuff 2 times for the week and do Cisco once?
we used to do Cisco twice, but then I was like, I need to get some sleep.
Okay. Okay.
So I was like, yeah, should I cut Cisco or Microsoft? But more people were interested in Microsoft than Cisco. So I'm like, yeah, let's cut Cisco. Yeah. Okay, guys. So we'll meet
Okay.
again next time. Yeah.
All
So
right. Thank you
have a
all.
wonderful
All
night.
right.
Yeah.
All right. Bye.
Yeah.
Thanks,
See you
guys.
later. Yeah. Bye
Yeah.
for now. Yeah.
Bye.